All right, so today we're talking about multiple representations of functions. So what does that mean? In previous lessons, you observed graphs that were linear, inverse variation, and exponential functions. In this lesson, you will investigate multiple representations of various functions, describe their patterns of growth, and describe characteristics of their graphs. Lesson 113A resource pages are attached. Study the pattern of tiles for tile pattern 1. And we're going to complete figure 4, and then we're going to look to complete the table and the graph. Okay, so if we look at this, this is one that is blank, that's incomplete. So the first thing it says is to, look for the pattern. So I've got 3 tiles along the middle, none above and none below. Here are my original 3. We added 2 onto the top, 2 onto the bottom, and 1 to the right. Here are my original 3. These are the ones that were added in the last image. So 2 more onto the top, 2 more onto the bottom, 1 more to the right. The last picture had these, and then we added 2 more onto the top, 2 more onto the bottom, and 1 to the right. So that pattern then results in this diagram. We can count up the number of tiles, 3 tiles, 8 tiles, 13 tiles, and so on. If you noticed, each time we were adding 2 to the top, 2 to the bottom, and 1 to the right. That means each time we are adding 5 new tiles as we go. So the pattern for this one, it said, describe the number of tiles and how they grow from figure to figure. So if we look at the original page, we would say, add 5 more tiles with each new figure. Describe the graph of the function. So what's the general shape? Well, straight line, so we would call it linear. From left to right, is it increasing or decreasing? Well, when I look at this, it's going up to the right, so that would be increasing. If you drew a line or curve through the points and extended the graph in both directions, what would the x and y intercepts be? Okay, so the y-intercept, where is it crossing the y-axis? We can actually see that it is crossing the y-axis at 0, 3. So the y-intercept is 0, 3. Now it says, what would the x and y-intercepts be? It's not possible to have an x-intercept because you would be in a negative figure and you would have a negative number of tiles. So this particular graph only makes sense in quadrant 1. Are there any values of x or y which are not possible? So x has to be 0 or greater, and y must be 3 or greater. So we'd say x is greater than or equal to 0, y is greater than or equal to 3, because the figure 0, the smallest figure number, had 3 tiles. We never had fewer than 3 tiles. All right. Find tile patterns 2, 3, and 4 attached. Be prepared to present your work for your class. So what we're going to look at are the different tile patterns. So what do we have? Tile pattern 2. We can have the 4 separate or the 4 in the middle. It does work either way. Here we've got 1 in the middle with 4 on the corners. Now we've built a square in the middle, same 4 on the corners. So really we added 3. Here we've got the larger square in the middle with the same 4 on the corners. So basically we're going 1, 4, 9, 16 plus the extra 4s. So here we had none in the center, if we're going to look at it that way, 0. So we had a plus 1, and then we had a plus 3, and then we had a plus 5. So tile pattern 2 was increasing by 1, 3, 5, 7, 9, and so on. So it was odd number increases. And so when we look at that, because the increase is a different number, we've got this curve and we've got an exponential pattern because the increase is increasing.